Assalamualaikum warahmatullahi wabarakatuh. Okay, so let us continue from the frame processing here. From the frame processing, okay, the explanation of this frame processing is in the previous video lah. Okay, so let us start. Okay, from here. Okay, so first of all, we need to know, okay, this packet ni. Okay, when we say packet processing, this packet is the data unit used for network layer. Okay, and network layer is layer 3. And what protocol in network layer? That forward packet or that process the packet, which is IP protocol. Okay, so that's why here, okay, one of the function of IP protocol is to do forwarding. Okay, is to forward packet. This is the the biggest contribution of IP ni is to forward packet. Okay? So now, in order to forward packet, so router ni, this router have to ni lah, check dia punya routing table. Okay, so before we talk about that, okay, first of all, we need to understand, okay, so how you get this packet ni. Okay, this slide suddenly, okay, you have a packet here. Actually, what happened? A frame arrive to this interface G000. Okay, this is a gigabit, okay, Ethernet interface. Okay, so Ethernet frame, okay, and you will receive a Ethernet frame, and then you do some processing with it. Okay, look at the destination MAC addresses. Okay, and then calculate the CRC and everything. When this is everything is okay. Okay, so what this Ethernet do? They will decapsulate this frame to become a packet. Okay, and bring to the upper layer lah. So this information, so this one IP header together with the data, this one we call it as a packet lah. Okay, how you get this from frame processing. Okay, this slide is about packet processing. Okay, so for so after you decapsulate the frame become a packet, now, okay, router ni have to look into the detail of this packet lah. Okay, so first, okay, we this one first. Okay, what the router will do, they will check the destination of this IP address. Okay, so the destination here is 172.16.10.1. So from this destination, they will check dia punya routing table. Okay, so here it happened that, okay, there is a entry in this routing table saying that if you want to go to 172.16.10 network, okay, /24, okay, network, so please forward this to the G001. This one is a next hop lah. Okay, next hop. Okay, next hop. Okay, I hope you still remember lah the routing table. Okay, you have an entry, and then you have a preference or cost, kan? And then you have a next hop too. Okay, next hop. Okay, so now, okay, now that router A knows where to forward. Okay, by looking at the routing table here, okay, the router A knows where to forward. It must forward this packet ni, okay, to G001. Okay, so what happened? Okay, router A, okay, router A, knowing that it will forward the packet to G001 here, and let us assume lah the next hop at G001 tu somewhere, let's say you have router B, okay. It's actually this router B is for the next slide here, RTB. Okay, so let's assume here you have RTA, I guess. Okay, so now from this router A, for example, you know that, okay, by looking at the routing table here, you know that you need to forward to through G001. Okay, okay, and here, okay, this RTB, let's assume here is G002, okay, for RTB. And what RTA or this router need to do is this router, when you know where to forward, okay, here G001, what you do, you form a frame, because end of the day, when you know the next hop, the most important part is, before you forward the frame, is you need to know the MAC address of this RTB, the MAC address of this RTB. To be specific, you must know the MAC address of G0002, which is the next hop in RTB. Why? Because when you have a packet, okay, this is the packet lah. This packet arrived just now. The same packet, you have data here and you have IP and the address is 172. So let's form a packet first. Let's say you have a packet here and the destination is still same. I mean 172.16.10.1 here, and also the data is still same. Okay, so you form this packet, okay, and you encapsulate this packet to become a frame. Okay, to be specific, a gigabit Ethernet frame lah, G001 here. So now you know a frame, you must have a destination. Okay, the destination of MAC address. Okay, and also so you must have a source MAC address. Okay, so the destination MAC address here, okay, is the destination of the MAC address in router B in the next hop. Okay, so here, let's say for example, here I just make an example lah. Let's say the MAC address is 0102030405 BB, for example. Okay, let's say for example here, the MAC address here is 01020345B here. So when you form, when A form a frame, they form a frame, the destination must be 01, 02, 03, 04, 05 BB, which is the MAC address of router B. So what is the source MAC address? So you need to look into here, what is the MAC address of this RTA here, okay? This MAC address, the MAC address of this interface will be the source of this frame, okay? So what happened, okay? So you have a packet here, okay? You have a packet here, the same packet that arrived just now, and you have a packet here, and then what you have, you form a frame, and the destination is the destination. Okay, cancel. Remove its content from all participants. Yes. Okay. Want to save? No. Okay. All right. Okay. Cancel. You want to save the document? No. Okay. Oh. Okay, let me share again lah. Data forwarding. So always happen. Okay. Okay, let's see. Okay, so oh. Okay. 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 So RTA will form a frame. Okay. So now let's assume that you have RTB here, and this RTB, okay, this problem. Okay, RTB here. Okay, the MAC address of this, let's say for example G00. Okay, here the MAC address is the interface is G002 for example. Okay, and the MAC address is 01, 02, 03, 04, 05, BB for example. Okay, so what the Ethernet frame, okay, in router A, okay, how you form a frame. So frame must consist of packet, okay, with the data, and this data ni is the same data that arrive lah, and the same IP packet here, okay, that you receive here. So the destination here is 172.16.10.1. So you encapsulate this packet and you form a frame. The destination of this frame is the MAC address of B. Okay, why? Because here in the routing table says that in order to forward to go to this destination, this is the interface G001. This G001, the ending of this G001 is at the RTB in this interface. Okay, so this interface, network interface, this is the MAC address. So when you form a frame from A to B, okay, so the destination of MAC address is the MAC address of B, okay, which is 01, 02, 03, 04, 05, B, okay. And the source MAC address, here is the address of this point. I mean G001 in router A, okay. So this is the source MAC address. Now you form this frame, you send to the to router B. So that's why they say that a new frame is constructed. So this frame is constructed. But the content is same, the same packet here that you encapsulate just now. Okay. So okay. So that part. So first they look at the destination of IP address. Okay. This part lah. When everything settled, you check checksum, everything okay, then you form a frame and send to the next hoop, and you need to find out, okay, the MAC address of this RTB. What if when you want to form this frame and you don't know the MAC address of B, then router A have to perform ARP process. Okay, so ARP ni is not only happen in host, it also happen in router. Okay, when IP want to forward through Ethernet, for example, and you don't know the destination MAC address, so you need to form ARP to get the MAC address of the destination MAC address. Okay. So now, other than that, okay, router also will look into TTL. Okay. TTL is the what is it? This value shows the lifetime of this packet. Okay. If this value is become 0, it means that this packet need to be discard. Okay, you cannot forward this packet. Even though you look at the destination, it's okay. The moment you want to forward, you need to check this TTL. If this TTL is 0, okay, how you get this 0? Okay, every time a packet go through a router, this value you will deduct 1 from the current value. Okay, let's say you have TTL equals to 5, you go through one router, then TTL become 4, and then you go through another one router, TTL become 3, and so on, until you the value is 0, then any router will drop this packet. Cannot forward a packet with a TTL equals to 0. So this is when the TTL value to reach 0, then you cannot forward the packet. Okay. Even though you look at the destination, okay, the moment you want to forward, you need to look into this TTL. Okay. And another part which is quite important, very important, is MTU. Okay. So when you want to forward a packet, okay, let's say in this forward a frame. In this example, you want to forward this frame, the one that you formed just now. Okay. You want to forward this frame. Okay. This frame you want to forward this frame from RTA to RTB. Okay. You want to forward this frame. Okay. So before the router can forward this Ethernet frame, okay, the router have to look into the MTU. Okay. This is a maximum transfer unit. Okay. What is this? Sometimes they say maximum transmission unit. Okay. Transmission unit. Okay. MTU. What is this? This is the maximum value that certain network can handle. Okay. Let's say, for example, you have Ethernet. In the example here, you use gigabit Ethernet. I guess we already look when we do lab, the lab today. We told you that okay, gigabit Ethernet they support until 9200 bytes of packet. This is very big. We don't we we don't call this as a frame. We call it as a jumbo frame. Continue. Okay, jumbo frame. Okay, so this is the maximum that the Ethernet can handle, the gigabit Ethernet. Normal Ethernet is 1500 bytes. Okay, so this is the size, the maximum size that you can deal with. Okay, when you want to forward the packet, the frame. Okay, according to this MTU lah, this one. Okay, so when you forward a frame from one router to another router, you not only use gigabit Ethernet. Okay, there's so many other data link layer protocol. Okay, like PPP for example, PPPoE for example. Okay, and HDLC for example. These are all data link layer protocols. Okay, that you can use in order to forward a frame. So this protocol also have their own MTU. Okay, so if you exceed the maximum value of this MTU, you need to basically do a fragmentation. Okay, so fragmentation, okay, I'll talk about that in the next slide. Okay, is where you make a big packet to become a smaller fragment within the same packet. Okay, so we talk about it. We will talk about that in the next slide. Okay, now that three part, destination, TTL, and then the MTU you need to take care of before you can forward the packet or the frame. Okay. Okay. So now, when you want to forward, okay, you have this destination MAC address here, and so this one I assume that you know, and the RTB MAC address. If RTA don't know what is the MAC address of this RTB, then this RTA must they know the next hop, but RTA don't know the MAC address of the next hop. Okay, so when you don't know the MAC address, okay, you must use ARP again. Okay, so that is the procedure lah. So let's go to the next slide. Okay, now here, okay, they talk about the frame decapsulation. Okay, so you assume here just now, in the example, you have RTA form a frame, and this frame, the content of this frame is packet, and the destination is 172.16.10.1, and you receive the frame from A just now. The destination here, okay, we assume this is a G002 just now, and we have the assume the MAC address is 01, 02, 03, 04, 05, BB. BB, for example, right? Okay. So now RTA just now, when they form a frame, the destination of the frame is 01, 02, 03, 04, 05, BB. Okay, the destination MAC address. Okay, this one, the assumption that we did in the previous scenario, destination MAC address here. Now, after RTB, okay, after RTB get this frame, okay, so this frame, okay, the destination of this frame is to RTB. So what RTB do? They receive this frame, then they do the processing part of this frame lah. Yeah. So RTB will check the destination. Okay, the destination is 01, 02, 03, 05 BB. The same with their RTB MAC address in G002. Okay, when it is same, then you check the integrity of that frame. Okay, if everything is okay, then you bring to the data here, the IP packet to you decapsulate and you bring to the network layer. Okay, that is exactly what happened lah. Okay, so you look at the destination MAC address, and then if it is okay, then you check whether it is correct or not. Then, okay, then what you do, you decapsulate. So the moment you decapsulate, okay, when you decapsulate, you need to look into the type field. Okay, when you want to decapsulate to the network layer have so many type of protocol. Okay, network layer here have so many types of protocol. You can have IP, you can have ARP, you can have so many other protocols in network layer. So to be specific, this frame will check the type. Okay, if it is 0x800 here, it means that this one is an IP packet. Okay, the frame and the content of the frame too inside the packet, this one is an IP packet. Okay, not ARP, not others. Okay, so Now, when they decapsulate, okay, they need to look into the type field, okay, and then bring to the network layer, okay. So header and trailer are discarded lah, because it's only to manage the what do you call this, uh, to manage the communication lah. So you take up the header trailer, discard it, and you take the packet and bring it to which protocol? To IP. How you know that you bring to IP protocol? You will look into the type field, okay, here. Okay, so that is what happened lah in frame decapsulation. Okay, so now, okay, now what RTB will do? Okay, again they will check the uh, the decapsulate. You will look into the destination of this 172. Now here, okay, as you can see here, RTB is a gateway to this network. Okay, look carefully here lah. So the nearest of this server ni, the destination ni 10.1 ni, okay, the server A is the destination actually. Okay, so the nearest router is RTB. There is no other router other than RTB, that nearest to server A. In fact, RTB is a gateway of this network. What network? 172.16.10 network. Okay, it happened that this server A is 10.1, this server B is 10.2. Okay, 10.2. But this one is okay, this router is considered as a gateway lah. Okay, it's not yet destination, but nearest to the destination. Okay, so when you look at this destination and you look at the routing table in B, now RTB understand that this RTB can forward the packet to server A. Okay, because if you check the routing table in RTB, server A is part of the local area network for RTB. Okay, so again, so now when you you know the destination, what the router will do? Again, they will form a frame. Okay, okay, I guess it's which one? Hold on. Ayolah. Okay. Oh, very difficult. Okay. Okay. So they will form a frame. I don't know where am I now. Okay. Okay. So that makes you move from hold on 13. This is 13. Okay. Packet. Okay. So this here. Okay, this one just now is there is a RTA. Okay. So server A is part of the local area network in B. So by looking at the routing table, okay, this RTB knows where to forward. I mean the IP address 172.16.10. Okay. So how you know? The next hop will be G001. Okay. It might come just now from G002. Okay, the packet and the frame just now. But when you process here, the RTB process the packet, they know that by looking at the routing table, okay, RTB know that it can forward the frame through gigabit 00 1, okay, to the server A. Okay, so now again the same process lah, kan? If you know the where to forward and it happened to the end destination to server A, now RTB need to form a frame, Ethernet frame to this destination. Okay, so RTB need to form a frame. Okay, need to form a frame again. So the data just now, kan, the IP, the packet destination is 172.16.10.1. Okay, and then you need to form a frame. The destination of this frame now is what? The destination is here lah. The destination, the MAC address of server A. Okay, it happened that 0800706 AA. Okay, just I put it here 0807 07 blah 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 AA. This is the destination MAC address of your frame. Okay, because you want to send it to server A. Okay, so if you don't know, the MAC address of A, then you form an ARP process again. Okay, so that's the process lah. Okay, for you to do, for you to forward the frame. Okay, so okay, server A, compare. Okay, so when you form this frame, you send this frame to server A. Server A, as usual, will process the frame. Okay, they look at the destination, the destination of this frame, which is in this case, the destination of this frame is 0807 AA. They compare this with its own MAC address here. Okay, it's same. So meaning that server A will process this frame, okay, because it's the destination already. Okay, so this one apa tu again lah kan, when server A receives, okay, now when server A receives the frame, okay, they receive the frame, they check the MAC addresses and the destination, okay, FCS, everything, the processing the frame, and then decapsulate the frame to become a packet. Okay, so remember, okay, always remember that when you are client or you are server, you have these 4 layers lah, 4 or 5 layers lah, network layer, data link layer, you must have transport, and you must also have an application. In this case, you are a server. Okay, so the decapsulation process to continue from frame decapsulate to become a segment, and then bring the data to the application layer. Okay, now after server A receive a frame, they process the frame, they decapsulate the frame and form a packet. So what will the server do here? Okay, they will check. Okay, server A here will check the IP address, the destination of this packet 172.16.10.1. Okay, this is you. Okay, this is a server A, which is the IP address of server A is 172.16.1, same. Okay, so when you look at the destination, okay, correct. Okay, I mean the destination mesh, then you know, okay, you know that you need to bring this or decapsulate this to the transport layer. To be specific, in transport layer, which protocol? You in transport layer, you can have so many protocols. Okay, UDP is connectionless. Okay, TCP, and then you can have RTP, MTP, SCTP, so many other protocols. Okay? So, how you know which protocol that you want to decapsulate to? You look into the protocol fill here. Kan? This one, if the value is 06, it means TCP. Okay, and there's also so many other values lah. If the value is 1, it is ICMP, and many more value lah. Okay? This value shows the protocol that will at the transport layers lah. Okay, now. Okay, so this part, the destination, okay. Now, if there is a fragment, okay, fragmentation just now. If you have a packet and a smaller packet that part of smaller packet or a fragment that is part of a bigger packet, for example, you need to reassemble this. Reassemble this. Okay. So as I told you before, this network layer ni, the responsibility is to forward and to do routing. Okay. So if you let's say for example you make it the data, I mean the packet to become smaller, become fragment for example, you need to be responsible in order to reassemble back. Okay, but you know that IP is a best effort. Okay, so when you make a packet to multiple fragment, let's say for example one of the fragment you cannot receive one of the fragment. Okay? When you reassemble, it's not complete, kan? So you have to discard. Okay, you have to discard this packet. Yeah? Although but because it's not complete. Okay, so if it's not complete, then the information in the packet is not complete lah. So you cannot process actually the packet. Okay, so now okay, apa tu? Let's say you have there's some details here lah. When you form a frame, when you form a fragment, for example. So how do you know the last segment? When the flag is equals to 0, then you know, okay, that will be the last segment in that packet, for example. Okay, I don't want to go through detail on this. Okay, enough for us to understand that the fragmentation happened, and this fragmentation, you have to reassemble back all the fragment to become one packet and process it. Okay, so if okay the destination match and then the fragmentation is okay, then only you look into just now what I told you lah. Okay, the protocol. You need to deliver, or you need to decapsulate this packet and take out the segment and bring to the transport layer. So this transport layer have so many other protocols. To be specific, which protocol that you want to deliver to, it depends on the value of this protocol header in IP header here. So not protocol header, protocol field in this IP header. Okay, so then okay, so you process the IP header. The moment you take up the segment and give to the TCP or TCP protocol in the transport layer, then you discard all the header and the data here. It's not the data lah, the segment here, kan? To be specific, the data unit is segment. The segment here is directed to TCP. Okay. Okay. So let's move to the next part. Okay. This one also we already discussed this. If you server kan, just now you have a frame kan, a frame receive here, you decapsulate to become a packet just now. Okay, and then you decapsulate to become a now segment. Okay, this segment is for transport layer. Okay, so because you're a server or client, you end to end. Okay, so you have your transport layer lah, you must process the the segment. Okay, if you realize all this while when we talk about router, we never talk about segment. Okay, we never talk about segment. We talk about frame, we talk about packet. Okay, we don't discuss anything related to segment. Okay, because this segment ni is a transport layer, and this transport layer is to support the application. So if you don't have application, no, so you don't need a transport layer to help you. Okay, so server, in this case, for example, you are a web server, clearly it is an application here, so you need a transport layer. In this case, a web application are using TCP. So after you decapsulate, everything settled, fragmentation settled, destination IP address settled, everything just now has settled, TTL or whatever, settled, then you go to the, you decapsulate and get the information of this segment. Okay, this is a TCP header lah. This is a TCP header. So there's so many information here. Okay, that you need to process. But basically, okay, basically when TCP receives this segment, the first thing that this TCP will do, TCP will check the destination port address. Okay, because TCP must know which application, okay, which application that this TCP, which application that you want to deliver to, okay, to web application, to email, to which application. Here you have an application layer here. So if the port number is 80, now you know it is a web application. In this case, it's a server. Okay. So if the value is 25, for example, oh, you know that, okay, you need to deliver this email. Okay, it's a text base, for example, okay, it's email. Okay, if it's a 21 or 20, for example, oh, you know that, oh, this one is a FTP application. Okay. Okay, so by looking at these port numbers, okay, port number is really important for you to know. Okay, so this one TCP ni, and TCP header ni, they will look at the services, which application that you want to give to the data by looking at the port numbers, the destination port numbers. Okay, you don't care much on the source port. When you receive this, what we call this, when you receive this segment, you must first look at the destination. Okay. Now, because this is a server, the purpose of client connect to the server is to get some data, some information from the server. So the server will reply, will serve or will give data to this client. Okay, so when the server give the data to the client, TCP will use this source port as the destination. Okay, so now the arrow here goes down here, meaning that it goes end to end to this client. Okay, if you want to form you send a data or you send a segment to this client, the port number that you should use is the source port number. Okay, the port number for the destination of your segment here is the source port number 1027. Okay, this destination source, destination port. To the client. From the client, okay, destination is port 80, port 80. Okay, so this is what this slide tells you. Okay, so in the example, they say that because later on there's a question related to this. Okay, I'll talk about that in the question session. The example can be understood that TCP connection has already been established. Okay. So here, why we discuss only on the destination port is actually so many other things. Okay, like Windows, for example. Windows is to control the number of segment that you want to send to your client, your server, right? Okay. So how the number of segment or the flow of your segment to the client. That is the function of Windows. Windows here. Okay? And every frame, every data that you get from web ni, you must tagging it. Okay, I mean put a sequence number in it. For example lah, kan? So you need to know that lah. Okay, that is also the function of transport layer. The 5 pillars lah. Okay, 5 pillars. But here, in order to forward the forwarding scenario, to forward and receive, the one that they care is on the destination, okay, of this port. Okay. Okay, so that's all lah. Okay, let's answer the question. What information is required before data can be encapsulated? So here they mention about the data, but the answer here shows that it's like apa tu a source must have a knowledge of IP destination. Okay, so probably this one is a packet lah. Okay, but this one they just want you to know, okay, before you can access to the internet. I mean, you access to the internet. Okay, what are the things that you need to know? Okay, you need to know the IP address of your destination. Okay, so this is the basic part lah, kan? If you don't know the destination, then it's difficult. So whether you want to forward it in locally or you need to forward it to go through the gateway and exit the local area network, that depend on the default address. Okay. Uh, 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 Default address here here means that that 0.0.0.0 tu lah. So I guess this thing explained in the previous video. Look into it lah. And then okay, so what happened when a frame is forwarded to a destination to which it is not intended? Frame kan, frame discard lah kan. Let's say you part of the bus topology kan, the destination is somehow is for this host, but you also receive this unintended, not intended to receive, but you receive it. Kan, so what you do, you just discard. Okay? Discarding is one major part of the framing, data link. Okay. Okay. Next question. How does the data in the frame? This one is wrong. How is the data in the segment? How does the data in the segment ultimately reach the application? Okay. Continue. Reach the application it is intended for. How does the data in the frame ultimately reach the application? This one, destination port numbers lah. Okay. So the destination port number will decide, okay, which application that you want to reach. Okay, port number. Okay. So the delivery relies on the destination port numbers in TCP and UDP. Okay. So that's it lah. Okay. Okay, the last question. Need to delete this one first. This question is a very good question. Why? Because in this question you have a new fact. Okay, new things like that that you need to know. Okay, so when you have multiple session, okay, in the same application are active. Okay, let's say for example, you open. Okay, this one for group 1, I describe detail, but okay, so let's look at here. Normally, kan, you imagine the normal scenario of you using your browser, kan? You open so many session, kan? Tab, tab kan? First, for example, is maybe a UPM website, for example, and then YouTube. The next step tu is YouTube, for example, kan? And then you go to watch. For me, sometime okay, I watch VTV, for example. So we open so many tab though, and basically you have so many session, multiple session on the same time, kan? And then Huawei website, for example, kan? So you want to find some for in the forum or documentation, for example, kan? So when this happen, dia kata the question say that ask you when multiple session on the same application are active, how does the written data reach to the correct session? Or this question. Okay, so now let's say for example, here this one you clearly know this one is client, right? This is web client lah. Web client means web browsers. Okay. Then you get you access to this UPM, for example. Okay, so now you have a server. Just now I just replicate the topology of this server A, right? And then server B here, for example, server B here, server B. Now you have server A here. Okay, this server you assume it is a web server of UPM. Okay, UPM web server, for example. Okay, so when you hear the client browse www.upm.edu.my, for example, these are the servers here. Okay, this is the server. Okay, so when you when when you connect, when you client you connect to the web server here, you must use port number 80. This is a must. Okay, so when we say well-known port numbers, we refer to the server actually. In fact, not only port numbers, the IP address of this server also cannot be. It must be public IP, okay, and it must be a permanent IP. You cannot use temporary. You cannot use temporary addresses for server. No matter what, the port numbers also must be fixed. The IP address also must be fixed. Okay, you imagine, let's say you demand some information from me. Okay, in the morning I'm using different phone number. In the evening I'm using different phone number, and it's difficult for you to connect to me. Okay, because I'm a server, so I need to have a fixed port number. So now the question says that when you have multiple sessions, it means that you are client already. You are not a what do you call this? You're not a server. So when you browse, you browse this UPM website, for example, the data that you get from the server here. So the server here, when they send the data to you, I mean the HTML tagging lah kan, not HTML, the HTML file, for example, when they send the data to you, this data HTTP data to you, okay, this HTML file, when they send to you, the question say, how does the written data reach the correct session? When they written to you, you are now browsing UPM, browsing YouTube, browsing VTV, browsing Huawei in different session. So how do this server know which one is www.upm.edu.my? Okay, how? By looking at the what? By looking at the source port here. Okay, so when you browse UPM just now, okay, you client, you browse upm.edu.my, that session on that tab, for example, are using port number 1027. So when you request that to this, let's say this is a UPM web server, for example. So when you request to the destination of server must be 80, but when the server reply to you, they must use this port numbers lah. This 1027 here shows that session in your web browser just now. So here they mentioned that okay, you can have this value. Sorry, so you can have this value. For example, UPM 1027. YouTube is 1110. For example, this is the port numbers used by the web client. Okay, so when you say this question, they want to ask you whether you know or not that when you have a well-known port numbers, okay, it's always refer the port numbers. This port number always refer to a server, and as a client, the OS, the Linux or Windows, for example, they can choose any port numbers lah, not any. That there's some numbers lah, but 2 to the power of 16 port numbers that you can use, okay, in order to connect with your server. But the server if web must be 80. But you as a web client, you can use any port numbers lah. Okay, not any, there's some regulation there, but basically you are freely to use port numbers other than 80 lah, even though they always say that okay, web client, web application is always 80. Email is always 25. Okay, so that is refer to the server lah. Email server must be 25. Okay, but if you have nowadays email you can open from so many tab also from the web server, for example, web application, for example. So you need that but okay, you need to have you need to have you can use other port numbers if you want to. Okay, the question to really ask you whether you know or not the function of port numbers in server and in client. Okay, I guess that's all. I'm very tired on this part. Okay, thank you very much. Okay, bye bye. 57 saat. Aduh.